Hello students, good morning. First question. Running at their respective constant rates, machine X takes 2 days longer to produce W widgets than machine Y. At these rates, if the two machines together produce 5 by 4 widgets, W widgets, in 3 days, how many days would it take machine X alone to produce 2 W widgets? Now, we have been given that machine X takes 2 days longer to produce W widgets than machine Y. So if I let that machine X takes X number of days to produce W widgets, then machine Y will take X minus 2 days, right? Because machine X takes 2 days longer, right? Now, 1 day production for machine X will be equal to, so number of widgets produced by both the machines are W. So 1 day production of machine X will be W by X, and 1 day production of machine Y will be W upon X minus 2. Right? Now, it has been given that at these rates, if the two machines together produce 5 by 4 W widgets in 3 days, so this is 1 day together production multiplied by 3 should be equal to 5 by 4 widgets, right? Or I can write, taking W common, 1 upon X plus 1 upon X minus 2. Here I can write 3W equal to 5 by 4W. So W gets cancelled and I would be left with, taking LCM over here, X into X minus 2. So X minus 2 plus X. So 3 will go to the right hand side and it will become 5 by 12. Right? So from here it becomes 2X minus 2 divided by X into X minus 2 equal to 5 by 12. This further implies, so I can write it over here. So here I can write, taking 2 common, I will get X 2 into X minus 1 divided by X into X minus 2 equal to 5 by 12. Now, so this will become 24 into X minus 1, taking 12 to this side by cross multiplication. So this will be 5. So this will be X square minus 2X. This will be further equal to 24X minus 24 equal to 5X square minus 10X. Now, shifting this to this side, so 5X square minus 10X minus 24X plus 24 equal to 0. This further becomes 5X square minus 34X plus 24 equal to 0. Now 24 into 5 is 120. So by splitting the middle terms, the product should be 120 and minus 34 should be sum. Now how I can bifurcate it? So if I break it into minus 30 and minus 4, so it will be, addition will be minus 34 and product will be equal to plus 120. So 5X square minus 34X can be written by splitting the middle term equal to minus 30X minus 4X plus 24 equal to 0. So you see, minus 30X minus 4X will be minus 34X, and minus 30 into minus 4 will be equal to 24 into 5, 120. So now taking 5X common, I will be having X minus 6. Here minus 4 common, so I will be having X minus 6 equal to 0. So taking X minus 6 equal to common, I will be left with 5X minus 4 equal to 0. I have made a separate video on splitting the middle term. I have solved a lot of questions over there. You can go and watch that video. So now either the value of X should be 6 or 5X minus 4 should be equal to 0. So that means 5X equal to 4 or X is equal to 4 by 6. Right? 4 by 5. Or X is equal to 6. Now you see over here that here it is X minus 2 and X. So X has to be greater than 2, right? So this condition is discarded. So we have value of X equal to 6. So what was originally X? X is the number of days taken by machine X to produce W widgets. Now we have been asked how many days would it take machine X alone to produce 2 W widgets. So if it takes 6 days to produce W widgets, so for producing 2 W widgets, I have to multiply it by 2. So here also I will multiply it by 2. So it will produce 2 W widgets in 12 days. So right option for this will be option number E, the right option. There is one more way to solve this. When you have written this equation, when you have made this equation W by X plus W bound X plus minus 2 equal to 5 by 12 W. So if you start putting the value of X as 4, so it will be 1 by 4 plus 1 by 2 equal to 5 by 12. So by putting the values, you will find that the right option will be option number E, 12 days. What is the greatest positive integer n such that 5 raised to power n divides 10 factorial minus 2 multiplied by 5 factorial square? So we have to find, we have done in the previous video same type of question. So first of all we will write 10 factorial minus 2 dot 5 factorial dot 5 factorial. Right? So basically we have to find the maximum number of 5 in this expression. So I can write this as 10 into 9 into 8 into 7 into 6 into 5 factorial minus 2 dot 5 factorial dot 5 factorial. Right? So taking 5 factorial common, I would be left with 10 into 9 into 8 into 7 into 6 minus 2 dot 5 factorial, or 5 into 4 into 3 into 2 into 1. Right? Now from this I have to take whatever is coming common. So this is basically 2 into 5. Right? This is 3 square, 2 cube into 7 into 2 into 3. Now here this is 2 multiplied by 5 multiplied by 2 square into 3 into 2 into 1. Right? Now first of all we will calculate the maximum how many 2's we can take common. So here it is 2 raised to power 4 and 2 raised to power 5. Here 2 raised to 2 raised to power 3 and 4. So I can take 5 factorial dot 2 raised to power 4 common, because here the maximum is 2 raised to power 4. Now I will see how many 3's can be taken common. So here it is having less number of 3's, so only one 3 can be taken. So 2 raised to power 4 and 3. And how many 5's can be taken common? Only one 5 can be taken common. So I will write 2 raised to power 4 dot 3 dot 5. So here now total number of 2's are 1, 4 and 5. So only one 2 will be left inside. Now we have to take only one 3 common, right? So this is this one. So I would be left with this 3 square, which is 9, and 5 at this 7. So I have taken one 5 common. So I have taken this 5 common. So I would be left with 7 only. So basically I have taken this 2 raised to power 4 common, one 3 common and one 5 common. So I would be left with 2, 3 square 9 and 7. Now here 2 raised to power 4 means this and this I have taken common, and one 3 I have taken common and one 5. So I will be left with only 1. So 5 factorial 2 raised to power 4, 3 and 5. So here it will be 9, 7, 63. 63 into 2 is 126. 126 minus 1. So this is basically equal to 5 factorial dot 2 raised to power 3 dot 3, 2 raised to power 4 dot 3 dot 5, and this is 125. Now in 5 factorial, if I expand it, it is 5 into 4 into 3 into 2 into 1. So this is 2 raised to power 4, 3, 5, and 25 can be written as 25 into 5 or 5 cube. Right? So how many 5's are there? 1, 3 and 1 over here. So maximum power of 5 raised to power n, where n will be equal to 3 plus 1 plus 1. So this will be 5. So n raised to power 5. So value of n is, the right option will be option number D. One side of a parking stall is defined by a straight stripe that consists of n painted sections of equal length with an unpainted section 1/2 as long between each pair of consecutive painted sections. The total length of the stripe from the beginning of the first painted section to the end of the last painted section is 203 inches. If n is an integer, what is n? Basically, it is the consists of n painted sections of equal length. And the length in inches of each unpainted section is an integer greater than 2. What is the value of n? So basically, the question is, there is a parking stall in which there has been some painted sections and unpainted sections. So this is like this, right? Now, it has been clearly said that it consists of n painted sections. So these are basically n painted sections. In between lies, these are painted sections, and unpainted sections lies in between them. And it has been said that unpainted section 1/2 as long as between each pair of consecutive painted sections. So if I suppose that the length of these painted section to be 2k inches, right? 2k, right? So this length will be equal to half of that. So this will be equal to k inches, right? Now, you see, whenever there are two painted sections, there is one unpainted section. If there are 3 painted sections, in between there are 2 unpainted sections, right? So it has been given to us that there are total n painted sections. So, and the length from first painted section to the end of the last painted section. So let us suppose this is the last, and in between there are n painted sections. So this is total 203. So if there are n painted sections, so the length will be n multiplied by 2k, right? So this is the length of the painted sections. So here n is equal to number of painted sections, right? Now there is one more thing that I told you, that if there are 2 painted sections, there is one unpainted section. So if there are n painted sections, so there will be n minus 1 number of unpainted sections. Why I am saying this? Because it has been clearly mentioned that the total length of the stripe from the beginning of the first painted section to the end of the last painted section is 203 inches, right? So this gives us that number of unpainted sections, that is n minus 1 multiplied by the length of unpainted section is k, because it is half of the length of the painted section. So this has to be equal to 203, right? Now if I open this becomes twice nk, 2nk plus nk minus k, right, equal to 203. So twice nk plus nk becomes thrice nk minus k equal to 203. If I take k common, so I will be left with 3n minus 1 equal to 203. Right? Now I will try to prime factorize 203. So 203 is basically, it is equal to 203 equal to 7 multiplied by 29. So these are the both prime numbers. So you must remember that it is a multiple of 29 multiplied by 7. So I can write this as 29 into 7. Right? Now two cases arise over here. First is when I take 3n minus 1 equal to 7. Right? 3n minus 1 equal to 7. So k becomes 29. Right? So from here 3n will be equal to 8 and n will be equal to 8 by 3 and k will be 29. But it has to be clearly written that if n is an integer, so n here this is not an integer, so this value will be discarded. Now second case will be when 3n minus 1, now here I have taken 3n minus 1 equal to 7, so here I will take it equal to be 29 and k becomes equal to 7. So here 3n will be equal to 30 and n will be equal to 10 and k will be equal to 7. Right? Now what is the value of n? So that will be the option number C. Option number C is the value of n, which is 10. Now since we have solved the question, we will try to analyze it. Now see, n is equal to 10, right, and k is equal to 7. So here I'll put the value of n to be 10 and twice of k will be 14 plus n minus 1 is 9 dot k is equal to 7. So this is 140 plus 63 and must be equal to 203. So 140 plus 60 is 200 and 203 inches. So we see that the equation is true. So the value of n will be 10. So this is just analysis part. Otherwise we have solved the question. So there is another question. 2 3 by 5 minus 1 2 by 3 whole divided by 2 by 3 minus 3 by 5. So we will try to solve numerator and denominator independently first. So numerator is in the form of mixed fraction. So 2 3 by 5 becomes 5 into 2 10, 10 plus 3 13. So 13 upon 5 minus 3 into 1 3, 3 plus 2 5, 5 by 3. So LCM will be 15. So 15 divided by 5 is 3 and 13 into 3 is, so we multiply 13 into 3 39 minus 15 divided by 3 is 5. 5 into 5 will be 25. So this comes out to be 39 minus 25 is 14 divided by 15. Right? Now numerator is 2 by 3 minus 3 by 5. So this is basically 15, or you can do by this. This is 5, 10 and here 2 and here it will be equal to, see, 15 divided by 5 is 3, 3 into 3 is 9. So this will be 1 by 15. Now I can write this, combine this numerator and denominator, 14 by 15 upon 1 by 15. So this will be equal to 14 by 15 into 15 by 1. So 15 gets cancelled, I will be left with 14. So right option for this will be option number B. Now we will solve some of the statement based questions in which we will be given one statement and then there will be two options in the name of 1 and 2. Now here the options are in such a way that if you select option A, that means statement 1 is alone sufficient, right? And if option B states that statement 2 is alone sufficient, statement 2 is alone sufficient. If you select C option, that says that statement 1 and 2 together are sufficient. You must remember this sequence is sufficient. 1 and 2 together are sufficient. Option D states that both these statements 1 and 2 independently are sufficient, right? And E states none of the statements 1 and 2, none of the statements are sufficient, right? So you must remember this, that if statement 1 alone is sufficient, then we will mark option A. If statement 2 alone is sufficient, then we will mark option B. If both together are sufficient, then option C. If 1 and 2 are independently sufficient, then option D, and last is none of the statements is sufficient. Now we have been given the question that does 2x plus 8 equal to 12, right? Now from here I can find out the value of x. So this implies that 2x is equal to 4 and x is equal to 2, right? So this is the question part which I have given. Does 2x plus 8 equal to 12? Now statement 1 states that 2x plus 10 is equal to 14. So 2x should be equal to 4, and this implies that x is equal to 2. So this justifies the value of 2. So that means statement 1 is sufficient. Now we'll see for option number 2. Option number 2 states 3x plus 8 is equal to 14. Right? So this implies that 3x is equal to 6, 14 minus 8, shifting 8 to this side, transposing 8 to the right hand side. So this implies that x is equal to 6.3, which is 2. So this statement is also sufficient. So that means because they are both giving the same value for x, so that means statement 1 and statement 2 independently are sufficient. So for this, the right option will be option number D. Both 1 and 2 independently. So you would remember that if one statement, second, this is 1 plus 2, this is 1 comma 2 both, and this is 1 comma 2 neither. Right? If M is a set of consecutive even integers, is 0 in the set M. Now we have been given in the statement that M is a set of consecutive even integers. Right? Now we have been asked that if 0 lies in this set M. Right? Now first statement is minus 6 is in set M. Now if in set M I am having minus 6, right, and it has been given that it is a set of consecutive even integers. So but we don't know whether it is like this minus 8, minus 10, because minus these are also set of consecutive even integers, or I don't know if I move to the right side, so I will write minus 4, minus 2, and up to what point either I can stop here, or there may be chance that it may be like this minus 4, minus 2, 0, plus 2. This can also, but this is also a case, this is also a case that it might consist of only 3 consecutive integers up to this and 0 is not included, and there can be a case if 0 is also included. So statements 1, I can say statement 1 is not sufficient. Right? Whenever there arises a case may or may not be, then you can say that the statement is not sufficient. Right? The statement must be, it must be like must be. So here by saying this that minus 6 is in the set M, I am not sure that whether 0 is in the set M or not. But taking a look at the second statement which says minus 2 is in set M. So this means basically again the same thing. I can write the set like this: minus 2, minus 4, minus 6, minus 8, minus 10, so on. Right? Or I can write the set in like this: minus 2, 0, 2, or it may contain only 3 consecutive even integers, or it might contain minus 2, 0, 2, 4, 6, 8. Right? So here also it is in a may or may not be condition. Right? May or may not be. Because I have been not precisely given how many sets are there. It might be the set of negative integers. So in that case, it might be this set. So statement 2 is also not sufficient. Now in such a case, when both statements are not sufficient, we have to combine the statements to see whether option C, for option C. Because individually A option says statement 1 is sufficient. This is not in this case. Statement B, statement 2 is not sufficient. Statement C, now statement D says individually both statements are sufficient. So this is also not a case. Fine. So now I will look for option C, and if option C is not possible, then option E, that both of the statements are not sufficient. Now if I combine statement 1 and statement 2, that gives me that combining statement 1 and statement 2, it gives me that minus 6, minus 2, so that means minus 4, minus 2, because we have to consider consecutive units. So minus 6 and minus 2 are in the set. Right? So it might be the case that it can be arranged like this: minus 2, minus 4, minus 6, minus 8, minus 10. It can be like this, or it can be like this: minus 6, minus 4, minus 2. Only these sets. So both the statements combined are also not able to give us the whether 0 is in the set M or not. So the condition is may or may not be. So in that case, I would mark the option E. So option E in this case is the right option, that together both statements are not sufficient. A box contains only white balls and black balls. So a box contains white balls plus black balls. What is the probability that a ball selected at random from the box is white? So we need to find the probability that the ball selected is white. Right? For this we must know the total number of balls, right? And in numerator we must know number of white balls or number of black balls. Why I am saying number of black balls will be also suffice, because if I know the number of total balls and they are basically only white and black, if I am given the number of black balls, then I can subtract and find the number of white balls. Now, this is the analysis now taking to the statement 1. Statement 1 says there are 100 balls in the box. So, which gives us this total number of balls. So, probability for white will be equal to total number of balls 100, but we don't know in the numerator what is the number of white balls. So, statement 1 is not sufficient. Now, statement 2, there are 40 black balls. So, individually, now when you are considering statement 2, you have to forget the statement 1 that we have been given 100 balls in the box. So, probability of white is equal to, so we are not given the total number of balls, or we are being given 40 black balls. So, since we are not given total number of balls, so we can't calculate number of white balls. So, statement 2 is also not sufficient. Now, combining these statements, which comes to, when I combine these four statements, I come to know that total number of balls is 100, and here I have been given 40 black balls. 40 black balls. So, if there are 40 black balls, that means that it is having 60 white balls, right? White came, 100 minus 40 will be equal to white balls. So, this will be equal to 3 by 5. Right? So now I am able to calculate by combining statements 1 and 2. So for this I will say option C, which means that statement 1 and statement 2 together can solve this question. So option C is. If they had been case that the statement given would have been able to solve independently, then I will go gone for option D, that our statement 1 and 2 independently are sufficient. But for this, if I combine both the statements, I will get the probability that a ball selected at random from the box is white. So right option is option number C. Rita's monthly salary is 2 by 3rd Junetha's monthly salary. What is their combined monthly salary? So in statement we have been given, so let us suppose Rita's monthly salaries are and Junetha's monthly salary is J. Now we have been given that R is equal to 2 by 3 of J. Right? So this has been given in the statement. So we can apply whatever is given to the statement with the help of either statement 1 or 2. Now R is equal to 2 by 3. Now we have been asked what is their combined salary. So combined salary will be R plus J. So if I put 2 by 3 J in terms of R, so I will be getting 2 by 3 J plus J. Taking J common, I would be left with taking 3 LCM 2 plus 3. So which is basically equal to 5 by 3 of J. So their combined salary is basically equal to 5 by 3 of J. Now moving to statement 1. Now statement 1 says that Rita's monthly salary is $4. So that means I have been given R is equal to $4,000. Now since I know that R is equal to 2 by 3 J, so I can calculate J from here. So J will be equal to 3 by 2 of R, right? So R is 4,000. So from here I can get 2,000. So 6,000, right? So R plus J is 10,000, right? So I can say that statement 1 is sufficient, right? You need not to solve every time. If you have come to know that with the help of given variables, statement 1 is sufficient, then you can go for the option A. But you have to see whether option B is also correct. If option B is also correct, then we can mark option D, because that says that statement 1 and 2 independently are sufficient. Now we will go with option. Now we will study option 2. Either Rita's monthly salary or Junetha's monthly salary is 6,000. Now it says that either, so either means R is $6,000 or J is equal to $6,000. Now we have to analyze both the cases. Now if R is 6,000, then Junetha's salary becomes 3 by 2 of R, so that will be 6,000. So in that case this will be 3,000. So this will become 9,000, and R plus J will become $15,000. Now if J is equal to 6,000, then R will be equal to 2 by 3 of 6,000. So that will be 2,000, and this will be 10,000. Sorry, 4,000. So R plus J will be 10,000. Now you see from the second statement we are getting two combined salaries, 15,000 or, but we are not sure which one is true. So option D is also getting cancelled. So for this the option A, that statement A alone is sufficient to answer this question. So this is the right option. You would mark with option A. Fine. Had it been both of these would be giving us the same answer. Fine. In that case R plus J should have been 10,000. Then we have said that option D, which says that statement A, statement 1 and statement 2 alone are able to solve this question. Each of the 120 students in a certain dormitory is either a junior or a senior. How many of the juniors have credit cards? So from the open statement we have been given, let us suppose the number of juniors be J and number of seniors be S. So we have been given that J plus S is equal to 120. Now we need to find how many juniors have credit cards. This is the only information from the statement. Now moving to the statement number 1. 2 by 3rd of 120 juniors and seniors have credit cards. So that means 2 by 3 of 120, which is equal to 40, which is equal to 80. So that means 80 juniors plus seniors have credit cards. So So, but this doesn't give us information about how many juniors have credit card. So statement 1, that means option A is discarded. Now statement 2 says, statement 2 is over here, the number of seniors who have credit card is 20 more than number of juniors who have credit cards. Now here it says that number of seniors who are having credit cards is 20 more. So I can write the equation like this, that number of juniors who are having credit cards is number of seniors. So SC is 20 more than the number of juniors. So I would write the equation like JC plus 20, right? So number of seniors who are having credit cards is 20 more than number of juniors. So I would add JC plus 20. This is what statement 2 gives. But this also doesn't give us information about juniors who are having credit cards. So option B is also not sufficient. Statement 2 is also not sufficient. Now we'll try to combine these both statements. So option D is also not possible because none of the statements are sufficient. So no statement is sufficient. Now from combining of statement 1 and 2, I come to know that total 80 juniors and seniors are having credit cards. And from here I get that seniors are number of seniors. So here I can write SC plus JC is equal to 80. From here I come to know from statement 1 that juniors and seniors who are having credit cards is 80. But here SC is equal to JC plus 20. So I can write JC plus 20 plus JC is equal to 80. So this implies JC, twice of JC will be equal to 60. Or I can write number of juniors who are having credit cards equal to 30. Right? You can stop over here also and mark the option C, just because you know that now I can find, which I have been asked to find, that how many of the juniors have credit cards. Now let's analyze this question a little bit. So number of seniors who would be having credit cards will be JC plus 20. So 30 plus 20 is 50. Right? So this is 50 plus 30. So total 80 juniors and seniors would be having credit cards. So JC is equal to 30. So that means for this, both statements together, not independently, together can help solve this question. Solve this. So right option for this will be option number C. Right? What is the value of integer x? So nothing else has been given. We have just to find what is the value of the integer x. So statement 1 says x rounded to the nearest 100 is 7200. So x rounded to nearest 100 is 7200. So now what does that basically means? That nearest to 100. So that means x could have the value 7201 also, 7202 also, 7203. So there will be a lot of values. So we can't be precise. So option A is not sufficient. Now the 100th digit of x is 2. Now the statement 2 says the 100th digit of x is 2. Now this statement tells us only that the 100 digit is 2. So I can have any of these like 0, 0, 2, 5, right? Or I can have unit tens, 2, 6, right? So there are n number of possibilities where 100th digit of x is 2. So this statement is also not sufficient, right? Now combining these both statements for looking for option C, because now if A and B are not true, then D is also not true, because individually none of the statements is giving us the value. Now if I combine, I get 7201 or 7202 or again 7203, because I have to just keep rounded to 7200. 100 to nearest 100 is same, and 100th digit is 2. So this also is not helping to find the value of x. So statement C is also not correct. So since all 4 statements are options are not correct, so right option will be option E, that none of the statements is sufficient. Right? So right option for this will be option number E. If the average arithmetic mean cost per sweater for 3 pullover sweaters and 1 cardigan sweater was $65, what was the cost of cardigan sweater? So now let us suppose, I suppose that P represents the cost of average cost of 1 pullover sweater, and C represents average cost of 1 cardigan sweater. Now I have been given that the cost of 3 pullover and 1 cardigan was arithmetic mean was 65. So that means thrice of P plus C divided by 4. So total number of items are 4 is equal to 65. Or I can write thrice of P plus C equal to 65 into 4, which is equal to 65 into 2 is 130. So 260. So from the main statement I deduce that 3P plus C is equal to 260, where P is I have supposed to be average cost of 1 pullover sweater and C to be cost of 1 cardigan sweater. Now I need to find what was the cost of the cardigan sweater. I need to find C. C is what you need to find. Now moving to statement 1. The average cost per sweater for 3 pullover sweater was 55. So what does that mean? That means that for 3 pullover sweaters, so P by 3 is equal to 55. Right? Or I can say total cost is equal to thrice of P is equal to 55 into 3, which is equal to 165. Now you can calculate the cost of C from here being 260 minus 165, which will be equal to $95. So I can say that statement A is sufficient to find out the cost of cardigan sweater. Now either option A now or option D states. If statement 2 is also sufficient, then I will mark option D. And if statement 2 is not sufficient, then option A will be correct option. Now, option 2 states that the most expensive of 3 pullover sweaters cost 30 more than the least expensive. So what does it say? There are 3 pullover sweaters of P1, P2, P3. Let us suppose I have arranged them in ascending order of their cost. So it says basically that P3 is equal to P1 plus 30. This is what the statement 2 says. Now, with the given aspect, I would try to put some values for this. So let us suppose P1, P2 and P3 are arranged in an ascending order of their cost. So let us suppose P3 is $60. So P1 will be 30 because it has been given that the most expensive, that is P3, is $30 more expensive than the least expensive. So I assume P1 to be the least expensive. So P2 can take any value. If I suppose, let us suppose I take the value of 40. Or in other case, I can take this value as 60. I will take this 30 or P2 will take 50. So any of the possible, there are more possibilities. So in any case, if I find from this, total is 640, 130. So in that case, the cost of cardigan sweater becomes 30. This is 130. So cost will be cardigan sweater 130. Here 110, 140. So 260 minus 140. Here it will be the cost 120. So this doesn't give us the precise value of C. So statement 2 is not sufficient. So I will go with the option number A. Option number A. Had it been, it would have given us a precise value of C, then I would have marked D because it says that both statements 1 and 2 are sufficient independently to answer this question. So here this is not an option. Option A is the right option. If P and Q are positive, is P by Q less than 1? So main statement tells us that P and Q are positive, and we have been asked that is P by Q less than 1. So if any of the statements gives us a concrete answer, no or yes, then we will say that this is the solution. Both we have to take care. Right? So first statement says P is less than 4. So what does that basically mean? That P can take value 1, 2, 3, right? So it is less than 4 and it is positive. We have not been given whether it is an integer or not, right? So we'll assume that it will be an integer. So P is equal to 1, 2, 3. Now Q can take any value. So if I take Q, the value of Q, let us suppose I take the value of P to be 2 because P has to be less than 4, and I take the value of Q to be 4. Then P by 2, that means 2 by 4 is equal to 1 by 2. So which says less than 1. So we can say that yes, P by Q is less than 1. But if P is equal to 2, let us suppose P is equal to 3 and Q is equal to 3. In that case, 3 by 3 equal to 1. So this is not equal to 1, less than 1. So we can say no. So from statement 1, we come out with the solution with the conclusion that may or may not be P by Q is less than 1. So statement A is not sufficient. Now, if I cancel statement A, statement D automatically gets cancelled, which says that both the statements independently are sufficient. Now we have to look for option B and C. Now, statement B says that Q is less than 4. Again, same condition. Instead of P, Q is less than 4. So I will write, let us suppose Q is equal to 2, right? And let us suppose that P is taking value 4. So 4 by 2 is 2, which is greater than 1. Or if I take Q, the value of Q to be 3, right? And let us suppose I take the value of P to be 1. In that case, that will be 1 by 3, which is less than 1. So again, may or may not be. Both greater than and less than 1 are coming out as the option, so may or may not be. So statement B is also discarded. Now I have to check for option number C, combining both the statements. Now here it says, when I combine both the statements, let us suppose that P is also less than 1, less than 4, and Q is less than 4 also. Let us suppose I take the value of P to be 2 and Q to be 2 also. So in that case, P by Q will be equal to 1. So is P by Q less than 1? No. Answer comes out no. Now if I take the value of P to be 1 and Q to be 3, so in that case 1 by 3, it is less than 1. So again, may or may not be situation is coming out. So I will say statement C is also not correct. So I would go with the option E, that None of the statements are sufficient to answer this question. So right option for this will be option number E. Thank you for today's lecture. We'll solve some more statement based questions in the next lecture. Thank you. Bye bye. Take care.